My name is Ravi and today I'm going to talk to you about nuclear physics. Nuclear physics is the study of atoms and the change they undergo in a nuclear reaction. An atom is simply described by Bohr's model of an atom. He describes the atom like our solar system. Each atom has a center called a nucleus with two types of particles called nucleons. The nucleus of an atom can be compared to the sun in our solar system. Planets orbit around the center of our solar system, much like the electrons in an atom. The two types of nucleons in the nucleus are called protons and neutrons. Protons hold a positive electric charge, whereas neutrons have no electric charge. Electrons, on the other hand, are significantly smaller than protons and neutrons, but still carry a negative electric charge of the same magnitude. Nuclear physics is based off of three conservation laws. The first conservation law states that, quote, the total number of protons and neutrons participating in a nuclear reaction is conserved, end quote. This means that the sum of all the nucleons will be the same before, during, and after the reaction. The second law states, quote, the total electric charge is conserved, end quote. This means that if the electric charge is zero, meaning the total number of protons and electrons are the same before the reaction, then the electric charge will be zero after the reaction is complete. The third conservation law simply states that the total amount of energy, including the binding energy, is conserved. If one were to measure the total mass of all the protons and neutrons individually, and find the mass of the nucleons of the atom, the individual particles would have a greater mass. This is due to the mass defect effect. The mass defect can be found by taking the mass of the individual nucleons and then subtracting the total mass of the nucleus. The mass defect is the cause of the binding energies of the particles in the nucleus. The total binding energy can be found using a form of Einstein's most famous equation, E equals mc squared, where E represents energy, m represents mass, and c represents the speed of light in a vacuum. The equation can be converted into the total binding energy equals the mass defect times c squared. The binding energy per nucleon can be easily found by dividing the total binding energy by the number of particles in the nucleus. The more binding energy in the nucleus, the greater the stability of the atom. When radioactive atoms become unstable, they tend to spontaneously decay. During this process, the atom splits and particles such as neutrons, protons, and electrons are released in various forms. The main function of nuclear reactors around the world is to manipulate atoms in order to create energy. They generally work through a process called nuclear fission. Nuclear fission is one of the results of bombarding the nucleus of an In some cases, when a nucleus is hit with a neutron, it will just bounce off, causing almost no change except increase of the velocity of the atom. A neutron can also be absorbed into the nucleus of the atom without splitting the atom right away. However, it causes the atom to become unstable and will eventually split anyway. Nuclear fusion is essentially the opposite of nuclear fission. Nuclear fusion is the result of two lighter atoms bonding together to form a heavier atom or an atom with a greater atomic mass. However, this process requires a great deal of energy and therefore is only useful when two atoms that are lighter than iron fuse together, because they are the only atoms that will produce more energy after the reaction than it takes to initialize the reaction. This process is very difficult, and scientists are still working on mastering it today.